Hi guys. So we're going to start with the diverging lenses or the biconcave lens. It's very similar to the diverging mirror or the convex mirror. Um, Hopefully everything makes sense. I'm going to go through every single possibility. We're going to talk about all the different parameters and what their signs are. So hopefully everything makes sense and you guys understand it. So we always start by drawing the principal axis. There you are. And we're going to draw the biconcave lens. Now remember I showed you the shorthand way of drawing a biconvex lens. This is the shorthand way of drawing a biconcave lens. So it's kind of like an arrow with the arrowheads pointing towards each other rather than away from each other. So you're going to maybe pardon the noise a little bit. There is some street cleaning going on outside, so hopefully you can hear me. The first thing that's important to draw are always the focal lengths and the centers. So I'm going to go ahead and do that. I'm just going to pick them. Always remembering that the center is 2 times the focal length. And in this case, we're going to start with the object being away on the other side of C. So C and beyond, so further away than C. So let's draw the rays, and we always remember our rules. The rules are you always go through the focal point, and then through the first is parallel, and through the focal point. But however, in this case, we have a diverging lens. So actually, our rays get diverged after hitting the lens. So you have to work backwards in order to find out where it hits. All right. So this is a diverging lens. The next one is through the focal point and then parallel. And in this case, we're going to use this focal point, and then it's going to be parallel here. All right. Now what's going to end up happening is you're going to have this point of intersection right there. All right. And that's where our image is going to be. All right. Now, if you didn't understand what I just did, that's okay, because I'm going to do it 2 or 3 more times with the other setups. So don't restart it yet. Wait until I explain everything, and if it still doesn't make sense, go back and rewatch the whole video. All right. So what can we say about this image? I mean, first of all, we know that the object is positive. The distance of the object is positive. In this case, because the image is on the same side of the lens as the object is, the image is going to be virtual. So in other words, the distance of the image is going to be negative, and I'm going to, in brackets, write down that it's virtual. As for the height of the object, it's right side up. The image is also right side up. However, the magnification, what can we say about it? We can see that it's smaller, but we know it's positive because it has the same orientation as our object. So in this case, the magnification is going to be less than 1, right? But definitely greater than 0 because it's not negative. So the magnification is less than 1 and greater than 0. So this kind of looks a little bit messy here. So I'm just going to make sure that you see this is a different thing. All right. So the magnification is less than 1 but greater than 0. All right. And in this case, because we're dealing with diverging lenses, f is always negative. All right. So remember, when it's diverging anything, so if it's a diverging lens or a diverging mirror, it's going to have a negative focal point. And if it's a converging lens or a converging mirror, then it's going to have a positive focal point. All right. So now let's move on, and we'll do the situation where the object is on C. I'm going to draw my principal axis. I have my lens. I have my F and F prime. All right. And this time my image is going to be on C. Now, let's see if that even makes a difference. So let's draw the rays. I go parallel, and then, diverging, and extrapolate back to the F. And we have towards the F, but then here has to be parallel. And then we end up with a point of intersection, which is right here. All right, so we know where our image is. Let's determine what everything is. So at this point, you guys should be able to predict what things are going to be. So before I even say it, maybe you can pause the video and try to predict to see what's going to be DI, what's going to be DO, what's going to be F, what's going to be HI, what's going to be HO, what's going to be M. All right, so do that. Try to see if you can get it, and I'm going to give you the answers right now. So here we go. In this case, F is negative because it's a diverging lens. DO is positive. DI is negative because it's a virtual image. HO is positive because it's right side up, and HI is positive because the image is right side up. And finally, we can talk about the magnification. Again, it's smaller than the original, so it's definitely less than 1. But it's not upside down, so it's definitely more than 0. So our M is between 0 and 1. All right? And that's for the object on C. If you go back and try to remember about diverging lenses, or diverging mirrors, sorry, you'll notice that there's going to be a pattern here. So if you completely understand diverging lenses, diverging mirrors, you can stop the video right here because things aren't going to change really drastically. I'll go through the rest of them, but you should know that there isn't such a huge difference. So here the object is in between C and F. All right, and our image is right there. So again, let's go through everything. If you want to pause it to try and predict everything, go ahead and do that. And I'm going to go ahead and write down what the answers are. So the object is positive. The image is negative. The image is negative because it's virtual. The focal point is negative because it's a diverging lens. What else? The HO, the height of the object, is positive. Sorry, that's not an equal, but a greater than. The height of the image is also positive because it's right side up. And therefore, the magnification is the same as the other two previous examples. So less than 1, but greater than 0. Okay? All right, we're getting through this quick. Let's do the one on the F. All right, let's see what happens. So we have through F and then backwards. And then now what do we have here? We have something a little bit different, right? So the object is located on F. Theoretically, I'm supposed to be going through F. But remember, it's always the F on the other side when we're talking about diverging mirrors. So your image is right there. Was this a special case? No, not really. It's not a special case. In fact, if you shouldn't think of it as a special case because otherwise you get tricked. And I just got tricked because I thought I was doing it wrong. But in fact, it's just like any other diverging lens situation. So let's go ahead with those parameters. Again, if you want to pause it, now would be the time. So the focal point is negative because it's a diverging lens. The height of the object is positive because it's right side up. Same thing with the image. It's positive, so it's right side up. The distance of the image is negative because it's virtual. The distance of the object is positive. And finally, the magnification, again, the image is smaller, so it's going to be equal to, or less than 1, and then greater than 0. All right? And I'm not going to bother doing the one for between f and the lens because it actually doesn't change at all. It's just going to get, the image is going to always fall between f and the lens, and there is nothing really special about it. All right? Now, if there are any questions about this, please don't hesitate to ask me. I'd be happy to answer anything. And hopefully you guys all got this. So thank you.